Hello, geometry, and welcome to Unit 4. This is the unit that we are going to start geometry proofs. So a lot of people get freaked out when they hear that, but it's really not too bad. So here we go. Name congruent polygons. Use congruent statement to identify congruent parts and determine whether two figures are congruent based on certain information. So those are the learning targets. So let's jump in. We talked about congruence a lot in those learning targets. And congruent polygons specifically. Congruent polygons have congruent corresponding parts. All right, so the parts that match up are congruent in congruent polygons. Okay, when naming congruent polygons, always list corresponding or matching vertices in the same order. So you use your vertices to name polygons. And when you're naming two polygons that are congruent, you want to name them in the same order. Okay, so name those congruent polygons. So I'm telling you that those two are congruent because all the corresponding parts are congruent. Now, how do you know what matches up with what? Well, the first triangle I'm just going to name. So the figures that are congruent are triangle, and I'm just going to go RTS. It doesn't have to be RTS. It could be STR. It could be SRT. It could be, any combination. The first one does not matter. The second one, though, does. So congruent. Oh, before I go any further, notice that I have the symbol of triangle there. Okay. That's big. I referenced that earlier in the semester. Three letters names a plane, it names an angle, and now it also names a triangle. So you need to be able to differentiate. So you need that symbol. All right. So the second triangle, well, what matches up with R? You could go by look. Actually, you can't. Don't do that. Don't go by look. If you look at that marking there, it's got one line. On the other triangle, what has one little line? The F. So those match up. T is the next one. So T has a line with a little thing through it. Which one does that? It's D. And then the last one should be easy because it's the last one left, FDE. Okay. What you wrote right there. So what I just wrote right there, triangle RTS is congruent to triangle FDE. This right here is called a congruent statement or congruence statement. Right below the line. So when I say write a congruent statement, that is what I'm talking about. Okay. All right, moving down. This one, I'm giving you a congruent statement, right? I'm telling you triangle TJD is congruent to triangle RCF. List all the congruent parts. Well, I'm going to mark these, since I know they have to be in the right order. T has to match up with R. So I'm going to mark that. T matches up with R. J, I'm going to use 2 lines this time, matches up with C. And then D matches up with F. All right. Now, I can go a little bit further. If you look back at the previous one that we did, there were also markings on the sides, right? Well, TJ has to match up with RC. And JD has to match up with CF, which means the remaining 2 have to be equal. All right. So when it says list all the congruent parts, I'm not just marking on the triangle. What I need to do is I need to list them over here. So angle T is congruent to angle R. Angle J is congruent to angle C. Angle D is congruent to angle F. There's 3. Now you have to list the sides as well. TJ is congruent to RC. JD is congruent to CF. And the last one, TD is congruent to RF. Okay, so I could use the picture to do that. And the next problem, I didn't give you a triangle. So instead of using the picture, I'm going to use the actual statement. So look, notice it's the exact same question. List the congruent parts, list the congruent parts. You can do this without actually having triangles, because if you understand how a congruent statement works, you can start listing them out. Angle B is congruent to angle G. Angle K is congruent to angle W. Angle Z is congruent to angle A. Then you can go with the sides, and BK is congruent to GW. KZ is congruent to WA. And ZB is congruent to AG. All right. Notice how in both of those examples, the ones in red and the ones in blue, there are 6 congruent parts in a triangle. Now that's only in a triangle. All 3 angles and all 3 sides. That should make sense. Okay. Backside. What about not triangles? So we got pentagons here. It works for those as well. Now, there's more than 6 congruent parts here. There's actually 10, but you get the idea that I gave you that these 2 things are congruent with the statement. All right, and I'm going to use that statement to help match things up. So what matches up with W? Measure of angle W matches up with angle C, right? I'm honestly using the congruent statement more than the picture. But now I do have to look at the picture. What is angle C? It's 132. So angle W is also 132. Right? Angle D, what does that match up with? Matches up with angle S. We'll look at angle S. It is 88 degrees. So angle D is 88 degrees. Now the next one's a little tricky because I need to find measure of angle B. Well, B matches up with E, but I don't know E. Could I find E? Yes, I can. Angle E is the only missing angle in this polygon. It's pentagon. So pentagon has 5 sides, right? This goes back to what we learned in the last unit. How many total degrees are there? 5 sides minus 2 times that by 180. You should get 540. All right, and we know we have 4 of the angles there. Add those up. 90 plus 90 is 180. Plus 132 plus 88. You have 400 degrees out of the 4 angles already. And we actually have to add angle E in there. Subtract 400 and you get angle E is 140, which means angle B is 140. Okay, so we're using old stuff again. You should be used to that by now. All right. Are the triangles congruent? If so, give the congruent statement. To prove these are congruent, we have to show all 6 parts are congruent. At this point, we have to show all 6 points, or all 6 parts are congruent. So I'm going to give 6 statements here. I'm going to go ahead and make this a little bigger so I have room to write. All right. There's a lot of given stuff here. So I'm going to start with that. I'll start with sides. AB is congruent to ED. That's given with the fact that they're both 3. If they're both 3, they're congruent. All right. So now real quick, A, B, I named it from A to B. So I started at the one with the congruent marking like that to the right angle. So over here, same marking with A. Okay, I'm named them the same way. Small detail, but one that I do want to point out. Okay, next side, I'm going to go BC is congruent to DC. Again, that's given. So I've got two spots or two things done. Third one, also given, AC is congruent to EC. All three sides were given, weren't they? Those markings on AC and EC mean that those are congruent. The other two sides were given measures, and they're, since they're the same, they're congruent. Now we move to angles. Angle A is congruent to angle E. Again, that's given. So 4 of the 6 were given to us. 5. This is going to seem weird here. Oops. Angle B and angle C are right, RT for right angles. What's given to me there is that they're right angles. It's not actually telling us that those are congruent. It's telling me that those are right angles. And really, that doesn't really mean anything different because angle B is then congruent to angle D. Oops, I should have said that earlier. I said B and C. I meant to say B and D. Okay. And why are those two congruent then? Well, all right angles are congruent. All right angles are 90 degrees, right? So if it's two right angles, then they're congruent. So there's actually the fifth one. I need one more. And I can't say angle C is congruent to angle C. That doesn't make any sense because there's multiple angle C's. I need to name that with 3 letters this time. So I'm going to say BCA is congruent to angle DCE. Why are those congruent? We learned this one back in Unit 2, vertical angles theorem. Okay, so that's all 7 pieces, or sorry, 7 steps to say all 6 pieces are congruent. Now I can say triangle ABC is congruent to triangle, and A matches up with E, B matches up with D, and C matches up with itself. And the reason for that is, well, if all 6 parts are congruent, that's the definition of congruent triangles. Okay. Long proof, I know, especially hard when I'm writing with my finger, but last thing here, the congruent statement is what I just wrote. And that matches, you see that matches my last step. I'm going to show you that again here in a little bit on the last problem. Okay. Now there's a theorem that's kind of nice for us. I could have used this one in the previous one, but you didn't know it yet. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles of the triangle are also congruent. Let me just do a real quick example here. If this is 60 and this is 50, and then on another triangle, I've got this is 60 and this is 50. Well, if you do the triangle angle sum theorem, you know that the remaining angles should be 70, right? They all add up to 180. Well, if you do that on both triangles, they're both 70. Right, that's basically what that's saying. If I know 2 of them are equal, well, then the third ones have to be equal because they all add up to 180. All right, that's all that's saying. Now, can we conclude the triangles are congruent in that picture? Well, we've got two sides congruent marked. I gave you that J and N were congruent. J and N. I could say that these two angles are congruent because of the vertical angles theorem. And now because of the third angle theorem, I could say angle K is equal to angle M. So I've got 5 pieces congruent. However, I don't have these third sides. There's no third side theorem. There's a third angle theorem, but there's no third side theorem. So technically, no, not yet. Once we get to tomorrow's lesson, you will see that yes, we actually can, but with what I've taught you today, no, because I need the remaining side to be congruent as well. All right, last proof. So I gave you, what a lot of people are going to think is that this is a congruent statement. It's technically not. What this is what you're trying to prove, okay? My last step should be this. Once I say that in my proof over here, I'm done. Okay, so I need to get to that. Well, there's a lot of given information here. So I'm just going to list all the givens. Angle Q is congruent to angle S. I'm going to list all the givens, or not all of them, but angle Q, P, R. Why can I not say angle P? Well, there's multiple angles there at angle P. Is congruent to angle SPR. So both of those things are given. Now notice I focused on the angles there. We need one more angle, right? Well, I'll say angle QRP is congruent to angle SRP. Why? Just talked about it. That's the third angle theorem. I've got two angles congruent in the triangle on the left to two angles on the triangle on the right, which means the third angles have to be congruent as well. Okay. Next, I'm going to say PQ is congruent to PS. I'm also going to say that QR is congruent to SR. That's all given. But I have the same situation here that I had in the previous problem. I need that third side, and there's no third side theorem. So what am I going to do? Well, actually, on this one, I can do something. Do you see how PR is in both triangles? Well, the same line is congruent to itself. PR is congruent to itself. Why are they congruent? Well, they're in both triangles, but how can I say that those are congruent? That's a reflexive property. We talked about that back in unit 2. We didn't really spend much time on it. This is where it's going to come in. You're going to see the reflexive property used quite a bit in triangle proofs. Well, now I have all 6 parts congruent. Now I can say triangle PQR is congruent to triangle PSR. By the definition of congruent triangles. All right, I know that's a long because of the proofs. Hopefully that made sense. And good news is I'm going to shorten that up once we get to the next couple lessons.